challenge.
The Mars astronauts may have to wait in orbit until the dust storms settle. Planetary cartographer Ruslan Kuzmin helped NASA find landing spots for its robotic missions to Mars.
We have to be specific when choosing a landing site for humans. We must choose a site which is safe and is potentially suitable for future flights and landings. Our main tasks are to examine the water history and the possibility of life now and in the past. These criteria will determine the choice of the landing site.
In 1976, the Viking mission found no evidence of life on Mars. But it's possible that Viking landed in the wrong place, like looking for a jungle in Arizona. The manned mission to Mars will land in an area where it appears that water once flowed. Water means potential life, and scientists already know just where to look.
Mars also has presented us recently with evidence that liquid water has flown not just in the distant past or in the middle history of Mars, but also in very recent times. The Martian surface has, in many places, very discrete, finely incised gully system.
For the human mission to Mars, where to land is critical, but not as critical as the landing itself. After a 6-month voyage, the spacecraft is finally orbiting Mars. Now the crew must snap out of intense boredom and into action. Psychologists fear that they will be suffering from a syndrome known as attention tunneling.
Often in heavily automated systems, you can go from prolonged periods of boredom to moments of intense performance demand very rapidly. And you want to train people to deal with those transitions, those rapid transitions.
The Mars landing module separates from the main vehicle, which will stay in orbit. The exhausted astronauts now face the most dangerous part of the entire mission, entering the atmosphere and getting the lander safely to the surface.
Landing on Mars is hard because of many things. Number one, we have a large atmosphere, rarefied relative to home, to go through, with its own dynamics. When people, and even machines today, go to Mars, the last 50 to 100 kilometers are the most perilous.
Once the descent begins, there is no turning back. In less than 6 minutes, the crew will either be safely on the surface or they will be dead. The landing module is protected by a heat shield that will help slow the lander to keep it from burning up. Adam Stelzner is an engineer with NASA's Jet Propulsion Laboratory in Pasadena, California.
You're basically burning a hole through the sky on Mars, ionizing the atmosphere as you move through it, and punching a hole of burnt ionized gas. And that hot gas is looking constantly for methods of getting into cracks and burning the rest of the spacecraft up.
After entry, the lander sheds its protective shell. Weighing up to 60 tons, the lander hurtles through the Martian atmosphere.
8,000 meters.
NASA is experimenting with an inflatable heat shield to slow it down, so the astronauts don't burn up in the 3,000-degree heat of re-entry.
We decelerate at higher altitudes where there's less density but less air to be hitting, and so the heat generated is much less. And what this does for us, it allows us to land larger masses on the surface than we could ever put into a rigid aeroshell construction.
Picking up wind. Copy that. Switching to backup. Standing by for transmission.
Millions of kilometers away, the world must wait more than 11 minutes to find out whether the crew is alive or dead. Six months through space and 6 minutes burning through the Martian atmosphere, the lander touches down safely on the red planet.
Going to Mars is really a huge step for human beings. It'll be a big step for engineers, it'll be a big step for scientists, but I would tend to argue that it's going to be an even bigger step for humanity as a species.
After 11.5 minutes, word reaches planet Earth. then reality sets in. For the next 18 months, this hostile planet is their home. If anything goes wrong, there is no hope of rescue.
We will be operating basically out of the loop of handshaking with Earth, of calling Houston or Europe or wherever we run the missions. We will be doing it on our own.
You are go for EVA. Roger. Handle coming down.
The first time humans set foot on the planet Mars, we will be living on 2 planets. It will be a significant moment in history.
Months earlier, a series of cargo ships deployed food, water, supplies, Mars rovers, and living quarters. The astronauts' lives depend upon landing within a few hundred meters of the supply depot.
If you don't land near that stuff, you're not coming home. You know, if you're 200 miles off course and you have no vehicle with you that can travel 200 miles over the surface of Mars, you're going to die.
Their only hope of long-term survival is the Mars habitat, an interplanetary version of the motorhome. Only this camper protects against deadly solar radiation.
It does amazing damage to the top surface layers of your skin. And if you get subjected to it often enough, of course, the penetration to more sensitive organs in your body, the chance increases.
Outside the protection of the Mars habitat, the astronauts will face a world of deadly extremes. To work in a freezing, wind-blasted, poisonous atmosphere will require a space supersuit of unparalleled design.
To adjust your track racer.
NASA has already begun field testing a prototype Martian suit in Arizona's Meteor Crater.
86. One of our big challenges is mobility, flexibility, and what I would also group with that is weight, because there's a big trade-off between the two.
This new suit currently weighs 95 kilograms. NASA hopes to cut that weight in half before the Mars mission.
The spacesuit itself has its own life support system, its own thermal control unit, and enough mobility to get you around on the surface of Mars and protect you in this very hostile environment.
One of the astronauts' first tasks is to seek answers to the burning question, was there life on Mars, or is there life there still? Scientists seek answers in a remote desert on Earth. Like Mars, the center of Chile's Atacama Desert is a dead zone.
On Earth, we find little oases of death in a planet that's alive. On Mars, we'd be searching for little oases of life on a planet that's dead.
Astrobiologist Chris McKay is searching for life that could survive the hostile Martian environment. McKay has discovered microbial life in this waterless world, and he hopes his work will give astronauts a clue to where to begin their search on Mars. Life-seeking robots will assist in the search on the surface and in caverns where organisms might be protected from the deadly environment above ground. One such mechanical helper is NASA's Robonaut. Controlled remotely, its human